Here we want to solve the rational inequality and write the solution in interval notation. So the first thing we need to identify is if the rational inequality is in one term on the left side, which it is, and then we have 0 on the right side, which it also is. And now we're going to determine what are the critical points. So in order to find the critical points, okay, we take a look at the numerator. We have x plus 1 in the numerator. We're going to set that equal to 0 and solve for x. So we get x, which is equal to -1. So therefore, there's one of our critical points. And then in the denominator, we're going to have a restricted value because we cannot let that denominator equal 0. But it is still a critical point. So we're going to take x minus 3, set that equal to 0, and solve for x, and then we get 3. So therefore, those are our critical points. So now we're going to create our number line. We have -1 as a critical point, and then we have 3 as a critical point. And now we're going to create our regions according to the critical points. So we have region 1, region 2, and then region 3. And then in region 1, we're going to go from -infinity to -1. Now, -1 is not a restricted value, and it says less than or equal to. So therefore, if it's less than or equal to, we're going to have a bracket at -1. So this is -infinity to 1 with a bracket, -1 with a bracket. If we take a look at region 2, we still have a bracket at -1, but since 3 is a restricted value, we can't include it, so therefore it's going to have a parenthesis. So we have bracket -1 to 3 with the parenthesis. And then again, from 3, we know that we still have a parenthesis at 3, and it's going to go towards positive infinity, so therefore there are our 3 intervals. So the next thing now is we're going to test each region. So if we take a look at region 1, we can pick an x value of -2 and then plug it into the inequality x plus 1 over x minus 3 and see if that's less than or equal to 0. So if we take -2 and then we add 1, and then we take -2 and then subtract 3, and we want to determine if that is less than or equal to 0. So we get -1 over -5, which becomes a positive 1/5. And positive 1/5 is not less than or equal to 0. So it's false in region number 1. If we take a look at region number 2, we can pick the value of 0, and then we're going to substitute it into the inequality x plus 1 over x minus 3 to see if it's less than or equal to 0. So if we plug in 0 plus 1 over 0 minus 3, we get -1/3. And -1/3 is less than 0, so we can say it's true for region number 2. And then if we try region number 3, we're going to pick the value of 4. So we're going to plug that into our inequality. And so we end up getting 4 plus 1 over 4 minus 3. And so we get 5 over positive 1. And is 5 less than or equal to 0? Well, that is false. So we know it's false for region number 3. So where do we find that it's true for this inequality? Well, we can see in region 2, that is the only place where it's true, which is at bracket -1 to 3. And so therefore, our solution in interval notation goes from bracket -1 to 3.